the turning point?
We should probably get going so that we can try to keep on schedule. This morning I am pleased to introduce an old friend and colleague from the visual analytics community, David Ebert. David Ebert is a Silicon Valley professor of electrical and electronic engineering at Purdue, university faculty scholar, a fellow of the IEEE, and director of the Visual Analytics for Command, Control, and Interoperability Center, Vaccine. That is the visualization science team, and I'm part of this, I should have memorized this already, of the Department of Homeland Security's Command, Control, and Interoperability Center of Excellence. Dave's research has focused on developing visual analytics tools for emergency management, particularly for the U.S. Coast Guard community. His research team worked with the 9th U.S. Coast Guard District to develop a software tool called CG-SARVA that allows the Coast Guard to analyze patterns and resource utilization for the search and rescue mission within the Great Lakes. This work was recently awarded the Commander Atlantic Area's Excellence Coin. So here's Dave.
Thank you, Brian. So this morning I'm going to give you a little different flavor of topics that can be applied to crisis management than what you've seen over the past day. And I'm going to start off by introducing the center and the type of work that we do to give you some background on me and the work that I'll be describing. I'll try to introduce, for those of you who are not that familiar with visual analytics, what we're talking about for that and why it's relevant. And then I'll go through some examples that we've developed in different areas so that you can see it. And I'll conclude with what I think are some interesting challenges. And each time I look at this, I keep on adding more. So there's lots of work yet to be done. So here we were asked to create a slide describing our center in one slide. So we have a compressed map of the world in the middle showing the majority of our schools. I apologize, we're missing a few of our Canadian colleagues on there that we recently added. Then in the upper portion we have examples of the tools that we've developed and deployed. And at the bottom we have examples of the end users we work with. And I should mention that our center really, the difference between a center that is funded by the Department of Homeland Security in the U.S. as a center of excellence versus a center that's funded by our National Science Foundation or NSERC in Canada or DFG in Germany is the fact that we are measured not only on achieving excellence and expanding a research field and educating people, but the impact that we have and how we transition tools to end users so that the congressman and senator can be told what are they getting back for their dollar, what has it done to the public safety and the response capability of people in the U.S. So everything that we do starts with an end user and a problem, and that drives our research motivation and all the work that we do. And in my perspective, application-driven research leads to greater challenges and greater advances in research than faculty thinking about advancing their field and just looking at papers, because when you see the messiness and complexity of real-world data and decision-making environments that people deal with, it's much worse of a situation and a lot more challenges and aspects than I would ever think of. So it gives us a lot of good things to do. And the goal, you know, when I said we're supposed to be serving the Public Safety and Homeland Security community in the U.S., we're told that we're supposed to affect the 2.3 million extended Homeland Security personnel within the U.S. So what we do is really we've been focusing on people with sort of boots on the ground, the front lines people, local, state, and national level, first responders and groups. Here's a complete list of schools, and recently we expanded the schools that we're working with in Canada, so you sort of notice it just isn't because we're coming up here for a conference in Vancouver, but we've got a large portion of our team members now are working from Canadian schools. We also have European schools that are part of it. And the size of the school ranges from Navajo Technical College, which is a small tribal college in the Navajo Nation, to the large-scale universities such as the Purdue, Georgia Tech, Penn States, things like this. So we have a wide variety of people, and the goal is really to try to get the top people in the world to look at these problems. And as I mentioned, we have a wide variety of end users. Here's some examples of regional organizations and corporations that we work with. Here's some example of the national level and international organizations that we've been working with. So we really try to make sure that we have good community engagement and end user buy-in to everything that we do. And so really, the goal of the center is to help people make decisions more effectively through creating interactive visual interfaces and making sure that the information that's generated can be conveyed effectively and people don't misinterpret it. And while we do create things and help people understand through visual cognition information through graphical representations, we make sure that it's reliable, it's reproducible, and it's quantitative. I always use the example that I don't want someone doing neurosurgery on me because of a red dot from a volume reconstruction of a CT scan unless I look at the software. Because I've also worked in medical visualization and I know what goes on from taking signal data to a color on the screen. So we make sure that you get the number, you get the confidence interval, you know what percentage of the data contributed to that and which percentage of the data was not good for doing this. So we really try to allow people in the whole sort of crisis management life cycle from planning to detection to response and recovery, come up with techniques to help them do their job more effectively. And by building up new advanced statistical models and integrating simulations, we allow people to do proactive and predictive decision making through what we do. And I think that this, if you develop the tools effectively, they can help you through the entire range of situational awareness from perception through to projection. So that's sort of what our center is. Now if we want to look at what visual analytics is, this is an area that I guess it was probably around 2004, 2005? 2004 that the term was coined, and it really was derived from people trying to understand the massive amounts of data that are created today. And in the press in North America, there's been a lot of attention over the past 2 or 3 months to big data and big data analytics. But this has been an ongoing problem, and it was determined early on that automated techniques really are missing a key component to the process, that you really need to take advantage of what humans are good at and have human-guided techniques combined with automated data processing. So we really look at trying to help develop analytical reasoning capabilities facilitated by interactive visual interfaces. And the key components there are the interactive and the visual into this, and allowing people in this, I think of it, symbiotic relationship between the decision maker and the computer, come up with a way to guide their search, use automated techniques for what they're good at, use the human visual system and cognitive processes for what they're good at to solve the problem more effectively. And the people that we've worked with large-scale data sets, often if they try to apply machine learning, data mining techniques, they can't be effective. There was one example of people looking at a large-scale database where there were 65 fields that were being categorized, and they could come up with 80% accuracy from machine learning of previous data to automatically predict what should go into 5 of that large number of fields. And if you would have said yes, you would have had 95% accuracy. So the automated data mining and machine learning techniques can't handle a lot of the complexities in certain situations. They're great for a lot of applications. There's other cases where they fall short, so we try to integrate those techniques together with the human. And in doing this, it really requires an interdisciplinary background of people and expertise to this, ranging from traditional statistical and information analytics, geospatial capabilities, looking at scientific and high-performance computing, looking at visual ways of representing data, ways of handling large-scale data. Then you've got sort of the interaction science, cognitive science, design and communication. All of these contribute fundamental knowledge to create this field of visual analytics. And in order to do this, it then allows you to get these environments that can be proactive and predictive, but for them to be reliable, you really need to have the reliable and reproducible models and simulation. You need to understand the data and make sure that the data is handled properly. Now, it's a statistician colleague of mine who will, maybe a half an hour into meeting, someone's going around and asking for, what his take is on it, and he said, well, it really comes down to understanding the data. And if you don't understand the data, we're not going to get anywhere. And sort of a hush goes over the room, and they sort of have the view that this is a really deep insight. And it tends to work in every meeting I've been in with him. But it's key. Data that looks like it's comparable and you can apply the same techniques, if you don't look at the distributions and understand the skewness and understand the prevalence of zeros and errors in the data, you're not going to get the right information out. So that's really key. It's also important to understand what are the characteristics of the sources of data, what are the different types that you need to integrate, and then look at how can we actually correlate this. Can we pull out signatures from the data in ways that we can then start doing correlative analysis and comparison of these so that we can make the effective decisions. So those are a lot of things that we do, but in the end, really, we don't go in there and take people's data and go back with a solution to them. The first thing that I ask them is, what is the problem they're trying to solve? How have they traditionally solved the problem and represented it? And then what data is available to help with that? Because we're trying to create something that maps to the mental model that the user has for their problem space and solves the problem that they have at the given situation within the given time constraint. And it's important to remember in doing this, what is the role of a visual representation? It allows you to take the abstract and transform it into something tractable. It's good at highlighting features, anomaly detection, grouping, finding commonalities and trends people can pull out very easily. And you can use perceptual cognition and visual cognition. Perceptual cognition maybe is an oxymoron, but there's that borderline there that's quite important. If you look at visual cognition, which is a relatively new field, an area of study, how can we use that and augment it with these external artifacts, the decision-making process of the person, so that they can become more effective in the analysis process? So that's really what we tend to focus on. And hopefully that's giving you a fuzzier idea of what visual analytics is, probably from when you heard the terms to begin with, if you're not familiar with it. So you might, ask the question, why am I up here? Why was I invited? What's the relevance here? So when we look at crisis management and response, I see the role of visual analytics allowing you to do effective trend analysis, clustering, anomaly detection, going from the planning stage to looking at long-term analysis, making sure that you